Let's remind ourselves, what is the usual equation for a line of slope m going through x1, y1? Now, this is the discovery process. This is, I think, important to go through and make sure is understood, but it leads up to something that's going to be kind of quick and easy to use later. So recall that a slope of line containing, we've got a generic point xy and a specific point x1, y1, and that the slope must be m. So the phrase that says slope of line containing this point and that point, we apply the slope formula there and have y minus y1 over x minus x1. And that must be m, so that's set equal to m. Now this is technically already an equation for the line that we want, but now what we do is typically we just multiply both sides by the denominator so that we don't have to have this x minus x1 in the denominator, and we end up with y minus y1 equals m times the quantity x minus x1. So this is the point slope form. So given a point and a slope, the fastest way, really the fastest way to write an equation for this line is y minus y1 equals m times the quantity x minus x1. So the thing to do, just as a reminder from last time, is when you are using this form of a line, plug in for x1 and y1 and m and leave x and y alone. Now, I know that a lot of students don't like this form, but it is my expectation that you use the appropriate form each time. So if you just favor some other form of a line without looking at this, that is going to probably get you in trouble in this class. So please please pay attention to this form as well. Please don't ignore this form of a line. Okay, quick example. So we went through the exploration that led to this point slope form that's summarized in the first box. Now we can use what's in that box to find an equation for the line going through the point -8, 9 with slope 6. So it looks like this, real quick, right? So just plug in the pieces, plug in for x1, y1, and m, and then leave x and y alone. And you have y minus 9 is equal to 6 times the quantity x minus -8. In other words, x plus 8. Okay, let's take a look at find an equation for the line with slope 5/4 going through the point 0.7. So we can write this, yeah, y minus 7 equals 5/4 times x minus 0. Now that's already technically correct, but we could write a second answer just by taking the previous answer and adding 7 to both sides. So you have y equals 5/4 times the quantity x minus 0. Then outside parentheses you have a plus 7. Now, here's the same question with different wording. Okay, so it really is the same question, just the words sound different. Find an equation for the line with slope 5/4 and y-intercept 7. Now, since the y-intercept is 7, the line goes through the point 0.7. So we'd set up the same thing. Y minus 7 equals 5/4 times the quantity x minus 0. Then we could add 7 to both sides for a different answer. We could even simplify by not writing the minus 0, and you have y equals 5/4 times x plus 7. So, based on the example we just did, instead of having the slope 5/4 and the y-intercept 7, we could have slope m and y-intercept b, and we're going to run through the same process. It's another discovery. It's an exploration. Okay, so since the y-intercept is b, the line has to go through the point 0 comma b, and with this point 0b and the slope m, we just apply the point slope form, and you get y minus b is equal to m times the quantity x minus 0. Now we could add b to both sides, just like in the previous example we added 7 to both sides. We could even simplify the minus 0 by not writing it and have y equals mx plus b. I think this form of a line is more, let's say, familiar to people. It is the slope-intercept form, but it is actually built out of the point-slope form. That's the most natural way to come up with it. So if a line has slope m and y-intercept b, then an equation for the line is built as y equals mx plus b.